All right, hello everybody. This is a video demonstrating the Resko Safety B respirator throughout the third year in MSD. First, we're going to do a little member introduction. My name is Nolan Fairley. I'm one of the mechanical engineers on the team.
My name is Kyle Malloy. I'm the electrical engineer of the team.
My name is Caleb Hake. I'm another mechanical engineer.
I'm Ashley. I'm a biomedical engineer.
I'm Peyton Woodhouse. I'm also a biomedical engineer.
Right now, we're going to go over a problem statement and problem and team objectives. We are working with Resko Safety to create a respirator that bypasses the typical skin contact seal that is common with most commercially available half-face respirators. The key goal of this project is to create a design that is comfortable and easy to breathe through and passes industry-safe standard testing for respirators to ensure protection for the user, as well as improving comfort and compatibility with other PPE products we may see in our client-decided workspace. Shown now, as previously stated, this product has been in MSD rotation for the past 2 years. Shown above is the end of the second year prototype, which is showing a small face fitting respirator. The original prototype was designed with a single filter, no one-way valve, and a flexible bendy straw style connector. It intended to use a self-molded nose pillow and even included a saliva drainage feature that we later found unnecessary. This iteration failed quantitative port account fit testing because of the poor sealing and unrestricted airflow.
So as Nolan mentioned, our two biggest goals for this new body was to increase the seal and to increase comfortability through improved airflow and fit on the face. Here you can see our progression of the different designs that we created. We started off by adding multiple different components to help us achieve the two previous goals, mostly by adding a second filter, as you can see by the two threads on the design on the left. We also added a one-way valve and improved the nose connection, which we will get into more later in the presentation. Then from there, we took this design with all the components. We saw how bulky it was on the user's face. And so to increase comfortability and just overall look and compatibility with other PPE, we made further designs that just slimmed down the design that we'd created until it was the smallest that we could make it, and it felt the best on the face. Here you can see the final design that we'd made. It has a lot of improvements. Here you can see the aerial view. It's our most compact design. It's curved to fit the contour of the face. We took the mouthpiece connection and we pushed it further into the body of the respirator to decrease the extension of the respirator off of the face. This one decreased the weight felt by the user, so it improved the comfortability. It also decreased the extension off the face, so it allowed for other PPE to be worn with the respirator, such as a face shield. We also added grooves around the base of the threads for the filters to allow for O-rings to be placed beneath the filters and decrease air leakage in between the filters and the respirator to improve our seal. To increase the durability of the device, we also added a different way to connect the straps. In the past, the strap connectors were pushed into these slots, but doing that repeatedly would often break either the respirator or the strap connectors. So we moved to a thread and screw design where we inserted threads directly into the body of the respirator and put screws through little holes in the strap connectors so that they could be removed and replaced easily without worry about breaking the device or the strap connector.
As Caleb said, we did implement a one-way valve into this current design. This was due to failures that were happening around the mouth and nose piece when the user was breathing out. This implementation of the one-way valve created a designed exhalation point for air when the user was breathing. There was 3 different designs that we tested throughout this process. The first you can see on the left, we ended up implementing the third in our last and final design as it increased the amount of surface area and the likelihood of air leaking after the user breathes. We also implemented 2 different communication systems. This was due to the respirator utilizing both the nose and the mouth in the actual holding of the respirator itself, which caused limited verbal communication of the user. The 2 different communication systems included a nonverbal mechanical communication system, which you can see here, which utilizes a rotational yes and no dowel, as well as this and also the electrical communication system attaches to the bottom of the main housing system of the respirator.
The electrical communication system consists of 3 buttons that will flash either green, red, or both, depending on if you press yes, no, or emergency buttons.
We also developed a new nose component. So instead of using the bendy straw-like nose pillows, we bought CPAP filters. So we bought both the nose pillow and we also bought the face frame, and we were able to create a new connection point on the main body so that there were less opportunities for leakage of air. This design also proved to be more comfortable for users. And then our conclusion. We had very good results so far this semester. We were able to integrate an additional filter. We were able to make forward progression within the PortaFit count test. With each testing iteration, we got better and better results. We were still unable, though, to meet the client's expected value of greater than 200, which is a passing score. We were also able to integrate a working mechanical communication system and design of an electrical communication system.
And then finally, one of our biggest challenges was achieving a proper seal throughout the system. Seal issues negatively affected our port account fit test results, forcing us to refine the interface between all components. As the design continued to evolve, we also had to stay very coordinated as a team, consistently updating CAD models and communicating changes while balancing individual responsibilities. And finally, as previously stated, the EE communication system will need further work as well as further testing based on our procedures. Finally, just a special thanks to Phil Vancheri for helping with the port account fit test as well as feedback, and a special thanks to our client Joe Algier for our feedback and support throughout the entire process.